Hello, welcome to Biomedical Engineering Senior Design Demo, Team 5. I'm Hanning Lee. My teammate is Yiren Zhou. Our project is to design an EEG-based gaming app for pseudo-seizure prevention. Now I'm going to introduce this project and our optimum design. The human brain contains about 100 billion nerve cells called neurons. When the balance between these neurons is broken with abnormal and excessive electrical activity, a seizure occurs. Well, our project faces psychogenic non-epileptic seizures, which is not related to seizure or epilepsy, but it does have very similar symptoms, including sudden changes in behavior, movement, sensations, and unconscious emotional distress. PNES are mainly triggered by psychological distress, so traumatized people are likely to have PNES, especially for younger people. The uncertainty of when and where these symptoms will episode forces the patients to live with limitations, such as no more driving or swimming. Moreover, PNES commonly come with psychiatric comorbidities, such as ES and PTSD. There's only 5% of PNES patients who had no comorbidity. In a study about one-terms with PNES, there are 64% of one-terms found having PTSD, while 13% of one-terms were diagnosed with ES as comorbidity. Communications and accompany are essential for PNES treatment. PNES patients need considerable time and support from professionals, but most psychotherapies are expensive and limited supply. It is necessary to find a cheap substitute that can help to monitor and control a patient's condition in real time. We are aiming to design a mobile software that will mitigate the patient's stress and eliminate anxiety based on the feedback of a wearable EEG brainwave detector. The first goal of our project is to be affordable and accessible. Second, it should be simple and attractive. Third, it should relieve the user's mental stress and anxiety. And last, it should train users' stress control ability. Our main goal for this project is to manage the stress level of the patients by using a real-time biofeedback system. Here's a flowchart about our design. First, the patient needs to wear a headset that can detect their EEG signals and generate two numeric values, attention and meditation, that indicate patient's mental stress level. These signals will be transmitted to the phone through Bluetooth connection. Then, the game deployed on the phone will react to the signals. Now, I have some videos to demo our app. Before playing the game, we have to connect the headset to the phone. We trim the 20 seconds waiting here. After it is successfully connected, the player's attention and meditation values will be plotted on the graph, updating every second. The yellow line is the difference between these two values. After this, we can go to the game. The frequency of the dropping stars is determined by the ratio between attention and meditation values. So when my attention is higher, I got fewer stars. And as what we will see, as my attention got lower than the meditation value, I can get more stars. The more stars show up on the screen at the same time, the more difficult for the player to maintain relaxed, but more score can be collected at the same time.
Now it isn't presenting. So for the result part, we'll only test two subjects. Both of them are 21 years old healthy female. The figure on the left shows the trend of attention over meditation value within 2 minutes while they were playing the game. And the two subjects were playing the game every day within 2 weeks. The lowest attention value over meditation value of them were recorded in the right figure. Both of these figures represent a gradually dropping of the attention value over meditation value of these two subjects. So we can conclude that our app is working on these two subjects. However, due to the limited sample size, we cannot say that our app is working on the patient. For the future work part, because we do not test our app on patients, so the next important step is to test as many patients as we can to feed our database, so that our app can be more accurate and thus be able to provide useful advice to the patient based on their performance. We also need to store the EEG value of the patients so that the value can be provided to doctor for future treatment. Also, we should also design a reward system that will encourage the patient to play our game more frequently. Thank you.